Hi, in this video we're going to do some practice problems with reaction rates. So the first problem, the data here shows the changing concentration of dinitrogen pentoxide over time at 330 Kelvin according to the following process. And now we need to find the rate of a disappearance of N2O5. Disappearance is when we work with reactants. So it's going to be, we can use formula, rate of A is equal to negative changing concentration of A divided by time, which will equal to, we're looking for T from 0 to 200, so we're going to be negative change in concentration will be T final, which is 0.066 minus initial, which is 0.1, over time, which is 200 minus 1 minus 0. Now this 0.66 minus 0.1 divided by 200 minus 0. Put in a calculator, we're going to get 1.7 times 10 to the negative fourth. What will the unit be? Since changing concentration here, up here it's going to be molar, and down there it's going to be seconds. So, it's changing concentration over seconds, so our unit will be molar per second. Now we find the rate of appearance for NO2 from T0 to T200. So the timing is the same, except this time we're dealing with a different element. And since we're not given any concentration, we need to use stoichiometry. So we have 1.7 times 10 to the negative fourth, and this is N2O5. We can use, for every 2 moles of N2O5, there are 4 moles of NO2, as you can see from here. So this is basically multiplying the previous answer by 2, and 1.7 times 2 is 3.4 times 10 to the negative fourth molar per second. Next, we have an experiment that was conducted in, the length is 1.10, and the initial concentration was 0.75. Now we find the molar absorptivity coefficient A. So this is when we use Beer's law. Big A is equal to little a times B times C. And then big A, which is absorbance, is given here. Since our initial concentration, we're given the initial concentration, which is 0.75, so we're going to have to use an initial absorbance as well. So 0.77 when 0 seconds is equal to little a, which is what we're looking for, times B, which is 1.10 centimeters, times C, which was 0.75 molar, as given. Now we divide 0.77 by 1.10 and divide that by 0.75 to find A, which gives an answer of 0.933. Our units will be liters over moles times centimeters. Find the initial rate of the reaction. We can use rate of A is equal to negative change in concentration of A divided by time. 0.67 minus 0.77 divided by changing time, which was 30 seconds. And then this will be negative 0.67 minus 0.77 divided by 30 seconds will give an answer of 0.00333. The units will be molar per second again, since it's rate. Thank you for watching.